So remember, the A stands for anthropogenic. Anthropogenic factors can fall into two broad camps, deliberate and incidental. So deliberate and incidental. When we're talking deliberate, a lot of these things deal with construction, just earth movers. And so we have this picture from before. Look at the size of these, look at the scale that we're at, and now watch when we zoom back to a mining operation. These are giant dump trucks. These are backhoes like we saw in the last picture. This is the kind of operation that can and does swallow mountains. Other deliberate actions include classic farming techniques like plowing. So as you can see here, this field's being turned into something different than this field was. We also have incidental effects, so not necessarily deliberate, it's just a consequence of human action. This is a photo from on OSU campus, and so what we see here is the sidewalk comes up to about here, takes a 90-degree turn, and goes up the rest of the road. But what do humans want to do? Take the shortest path, take as straight a line as possible. And so what we're seeing is people cutting this corner, and as you can see, there's no plants growing here. They're being trodden under. Additionally, we're seeing extreme compaction. If you were to go to this site and try and poke a shovel into it, it would be very, very difficult. When you go by an area like this when it's raining, it will be flooded. Water basically does not penetrate this area. It simply wets the top and flows off, pulls into this low corner here, and runs off the sidewalk. Another incidental effect is the extreme case of contamination. So these are soil cores taken from along the Willamette River in Portland, home to one of the federal Superfund sites, which means it's so contaminated that the federal money is being spent trying to fix it. This red chemical is a precursor to DDT, and it's a legacy contamination from when industrial chemicals like this were produced and regulations weren't strong enough to keep industry from simply dumping it into the local area. All this time, as we've discussed the 23,000 years of agricultural history, or the 130 years since Dokuchev first proposed soil-forming factors, or just the not even a decade since Puyat amended Yenny's Chlorpt to highlight that human activity disproportionately affects soil trajectories. All this time, human population has been growing. So at the sites of the first settlements, often along riverways where there was easy access to water and typically fertile ground, these cities simply grow bigger and bigger. And bigger. Maybe adding a roadway. And increasing traffic. So we've got carts, drawn by horses. All the while, the land that's being lost, the land that's being developed as these houses increase, used to be farmland. Because what was the best place to grow all the food? Right where everybody lived, right where everybody ate. And so what we used to have is a very small city surrounded by a lot of farmland. But of course, as time grew, the city grew up around it, these farms disappeared and were built over. Beyond the obvious loss of farmland, another insidious effect was beginning to take place. As these places built and as technology advanced and the availability of materials increased, we start to see a lot of pavement, a lot of what we call soil sealing. And that's with an S. Soil sealing. Now what this looks like, I'm going to need some space to show you. All right, soil sealing. What we have in a natural environment is the lithosphere below, which is the soil, and the atmosphere above, which is the air. But as I said, with the city growing, pavement increased, and this brings this impermeable layer across. So if you see this black line, think of it as asphalt or something. It's separating the ground below from the sky above. And when rain comes, when any kind of precipitation event comes, it simply cannot pass through. And so that's what we mean by soil sealing. The soil itself is sealed against interaction with the atmosphere above. A common term you'll hear related to soil in the urban environment is the extensive use of impervious surfaces. This is basically just another way to talk about soil sealing. Like in the animation we saw, impervious surfaces don't let precipitation get through. And so while water is coming down from the sky, it hits the impervious surface, cannot pass through, pools up, and is typically, with modern city planning, routed as quickly as it can be to the local waterway. This typically results in elevated temperature as well as elevated chemical and fertility loads. What that means is we typically see algal blooms and eutrophication and dead zones. This is all encapsulated within something called the urban stream syndrome. The simplest way to talk about the urban stream syndrome basically means water flowing along before it reaches a city versus when it's flowing out. It can be good over here, like this can be okay. And then over here, it's very much not okay. Elevated temperature, which tends to kill fish. Increased chemical loads because it wasn't filtered. Increased chemical loads in the water because it wasn't filtered by the soil. And so that means we get greater algae growth. More algae means less oxygen in the water. And that means, again, less fish. And so this is where we get dead zones. I want us to look now at this image of the OSU campus during a recent phase of construction. If you see all this dirt, clear area, that's been compacted. It used to be a lawn. It's now been run over endlessly by trucks and cranes and bulldozers. They typically drop a lot of gravel to make it even more compacted so that it doesn't break away as all this heavy machinery is running over it. And this is happening all the time in all cities around the world, this same exact process. And so even if you're looking out at the city and it doesn't look as barren as this, they've like laid some turf over the top, this is what happened beforehand. This is what you can't see, but it surely still affects the soil today. One of the reasons this construction process has such a drastic effect is that soil weathers upwards. And so when these machines are coming in, they typically scrape out and remove all the topsoil and are left with this subsoil. Now, subsoil does not become topsoil simply by nature of being on top. Topsoil is chemically distinct from the subsoil. It has been around long enough that it has been chemically and biologically weathered. It is, again, chemically distinct from this soil. It is not the same fertility. And so the best that can happen is that topsoil that was removed gets reapplied, but of course it's going to be more compacted. It has been disturbed. A lot of biological life has probably been killed off because this soil has dried out while it's been waiting for the construction process to finish. We can have another look at that by seeing this. So, this is kind of like the natural soil area. We've got a pipe inclusion here for an oil well. There's been a bunch of digging and excavation, and ultimately this house has been installed, but now we've got a plumbed water line that's surely going to have an effect on these subsoil levels. We've got inclusion of trash material. We've got an application of a highway, so this is drastically increasing compaction, routinely increasing compaction along this route. This is an impervious surface, so it's going to lead to a lot more, it is soil sealing, and it's going to lead to a lot more runoff polluting local waterway. The last alteration of the human environment that we're going to talk about is this inclusion of material here. At best, it's innocuous in that it's just fill material from somewhere else. Maybe it's a bunch of gravel. It does alter the local soil texture, but at least it's still soil. The real problem comes from landfills, the inclusion of trash. Now, burying trash is not a new thing. People have been doing it forever, but for the longest time, all the stuff we made degraded. It wasn't really, I mean, even let's say the Bronze Age or the Iron Age or any of those metals still degraded. We, mined them, smelted them, concentrated them, and so even if an iron knife was discarded, that's a concentration of iron that is unnatural, but that iron would rust away, degrade, and eventually disperse through the local environment. Now we have plastic, and plastic doesn't degrade. A significant effect of plastic is just the fact that it doesn't degrade. And so in large pieces, its inclusion can separate soil media. And so if we had, a soil here with various horizons, if there's been a trash pit dug and now we have plastic, well, that plastic is impermeable to water. It's also often impermeable to air. And so roots aren't growing through it, water isn't passing through it, air exchange isn't happening, and so some areas could become oxygen deficient and lead to microbial loss. This is an especially pressing issue because since the invention of plastic from about 1950, we've produced globally about 9 billion tons of plastic. 9 billion tons. Since about 1950, the world's produced about 9 billion tons of plastic. That's 1,800 billion pounds. Most of this ends up in landfills. Some of it ends up in the ocean. Only about 9% ever been recycled even once. What this means, especially for the urban environment, is that you're facing an area that's been routinely soil sealed, excavated, refilled, and subject to centuries long of trash inclusion. Ultimately, all these aspects of the urban environment and the human effect on soil, this function A clorpt, has resulted in what is now called the urban soil mosaic. The urban soil mosaic says that traditional soil maps are no longer useful in an urban environment because they rely on natural processes which typically have smooth transitions across long time periods. None of this is true in an urban environment. There are artificial processes at work and everything is changing very quickly. So the urban soil mosaic says that as density increases, your lot size decreases and decreases, and then you have this full city. And so gone is the time of having this big yard, very, very small. And so as density increases, your lot size decreases, and the number of managers increases. This urban soil mosaic is a central tenet to understanding urban agriculture, to understanding your interaction with soil in an urban environment. You need to know that basically traditional knowledge of how soil works does not hold true in the city. You're going deeper into the city, everybody's sizes get smaller, and thus the number of people making different decisions about what to do with their land increases, and the trajectories of these soil diverge immensely.